Okay class, so today we're going to go through pressure in gases. I did go through it a little bit during the last lesson at school, but I'm just going to do a quick recap about it and then we'll go into the next part. So this is from your textbook page 158 and 159, 8.5 pressure in gases. Okay, so let's say we have two containers A and B. Let's say the width is the same, but this container is obviously, as you can see, container A is shorter and container B is taller. And if you see, I have drawn 5 gas particles in each of it. So here there are 5, 1, 2, 3, 4, 5. Here also 5 gas particles. Okay. Now in terms of volume, which one is bigger between A and B? So let's say I have 2 containers like this. One is bigger than the other, obviously. So if we look at it, this container holds 200 ml. Okay, of in this case is lotion. And this one is 20 grams of this cream. Okay, even without looking at the amount that it can hold, we obviously know that this has a bigger volume because it can hold more. So same thing here, between A and B there are 5 gas particles, but obviously B has a bigger volume because it can hold more particles if I were to add more particles. Okay, so question, between A and B, okay, which particles in which container has more free space to move? So obviously B, because B has a larger room. So you think of it as let's say your classroom, I fit 100 people in that one classroom. Okay, versus if I fit 100 people in the chapel. Which room will the children or the people that I fit the people in, which room the people will be able to move more? Obviously the chapel, because the chapel is bigger, more space for 100 people. So the same thing here, particles in container B are more free to move. More free to move meaning they don't have to squeeze so much or hit each other as much compared to container A, which will most probably hit the particles more, hit each other more compared to container B, which means they collide more with one another. So how much they collide, we refer to it as frequency of collision. Okay, how high is the frequency? High frequency of collision means it collides more. This one low frequency collision because it collides much lesser than A. So if they are going to collide more, their pressure will obviously be higher because they are more stressed up, they've got lesser space to move. So container A will have higher frequency collision, which means this will result in higher pressure. Okay, for this one it will be low frequency of collision, which means lower pressure. They're not too stressed up because they're not hitting each other as much, they're not very close to each other, so they're not as stressed up, and therefore there is less pressure. So when the frequency of collision is higher, the pressure is higher in a smaller container compared to in a bigger container where the frequency of collision is lower, which means pressure is lower. So this comes to a conclusion, a relationship between volume and pressure. So the lesser the volume, the smaller the volume, the higher the pressure. Smaller volume, smaller space to move. So because smaller space to move, the particles are so stressed up, so they experience higher pressure. So this is the first relationship we are looking at for gas pressure, gas law. Okay, the smaller the volume, that means the smaller the container basically, the lower the volume, the higher the pressure. So this is the first relationship between volume and pressure. Now why? Because when it is a smaller volume, the frequency of collision is higher, which means the pressure increases. So this is the first part that we'll learn, and after this we're going to look at the relationship between pressure, volume and temperature.